Okay, here's the second word problem in your notes for linear programming. And remember, we talked about how a lot of these word problems are centered around owning businesses, and that is the case with this one as well. So remember, our goal is to identify the constraints, the objective function, then we find the feasible region and identify the vertices to plug into the objective function. All right, so here's the word problem. It says a baker earns 15 cents profit per glazed donut, G, and we're just going to replace that. We're going to make the X and Y. And 40 cents profit per jelly donut, J, but we'll change that to Y. So it says if a customer wants to buy no more than a dozen donuts and wants to try at least one of each kind, what is the maximum profit the baker can earn? So again, we're going to make X be the glazed and Y be the jelly. Now we're going to identify what these numbers mean. So these numbers here are money related. So those are the ones that are going to go into our objective function, which we'll write in just a few minutes. The other things that we're going to identify are the constraints or the limitations. The limitation in this case is what the baker knows about customers. It says if a customer wants to buy no more than a dozen donuts, that means that the baker is familiar with the fact that most customers buy a dozen or less. The other thing he's familiar with is that a lot of customers like to try at least one of each kind. So the baker's not really limiting himself. He's basing his limitations off of what he knows to be true about the customer. So these are our two things that we're going to form our constraints from. So the first one says there can be that the customer wants to buy no more than a dozen. So the number of glazed plus the number of jelly is usually going to be less than or equal to 12. The customer usually doesn't buy much more than that. So this is not solved for y, so we do want to put it into slope-intercept form. So when we do that, this is going to be our first constraint. Okay, so now let's go on to second ones here. All right, so number 2, the rest of these constraints come from this phrase. The fact that the customer usually buys at least one of each kind. So that means that the number of glazed donuts is going to be greater than or equal to 1, and the number of jelly donuts is going to be greater than or equal to 1. Okay? So these are the 3 things we're going to graph. So let's graph those. First one says it has a y-intercept of 12. Now this graph only goes up to 10. That means we're going to have to count by 2's on each one of those grid marks. So if I want to go to 12, it's going to be 2, 4, 6, 8, 10, 12. So right there. And then the slope is negative, but it's negative 1 over 1. So it's just going to meet in all the corners, which makes it a little easy to graph. All right, so let's draw that in. All right. The other 2 constraints are both going to be horizontal or vertical lines. Since it only has an x, that's a vux. Since it only has a y, that's a hoy. So this one's a vertical line that passes through 1 on the x-axis. Now remember, I labeled these by 2's. So if this is 2, then 1 is going to be right there. So let me draw in the line for that one. There you go. And then this one is going to be a horizontal line that passes through 1 on the y-axis. The y-axis 1 would be right here because this grid mark is 2. So this one is 1. Now I can draw a horizontal line through that. I'm going to have to move that a little bit upwards. Okay. All right, so you probably can see the feasible region. The feasible region remember, I can start with one inequality and kind of gauge about where the feasible region is going to be. Since this line here, which is the slope line, says it's less than, it's going to be below, that means it's going to be part of this. But it's also limited by the fact that these are 1 and 1. So that's going to be right here up against that other two lines that I drew in there. Right there. So let's look and see if we can identify the vertices from there. So this one right here is a vertex. You can tell they're going to be in the middle if you're looking carefully. They're in between the grid marks, so you're going to have to count by ones for those. All right, so this first one right here is going to be the point 1, and then we're going to count up by 2s until we get to that halfway point. So 2, 4, 6, 8, 10, that's going to be 11. So that's 1, 11. This one is 1, 1. Oops. And then this one, we're going to count by 2s until we get to this grid mark and then count by 1s. 2, 4, 6, 8, 10. That's also 11, but that's the point 11, 1. So there's my 3 potential vertices. Now I do need to write out, because I have not done this yet, I do need to write out my objective function. I have not done that yet. So let me do that. Let me unfreeze this and see if I can move this. Right, let me do that. For some reason it does not want me to move that. Oh well, I'll have to do it over here at the bottom then. Alright, so let me write the objective function. The objective function, remember, comes from this, okay? 15 cents per glazed donut, 40 cents per jelly donut. So the objective function, or the profit, is going to be 0.15x plus 0.40y, because it's 15 cents for the glazed, 40 cents for the y, and I have to use decimals since these are in cents. So all I have to do now is take these values and plug them in here. So if I do 111, I'm going to plug in a 1 for the x and an 11 for the y. And of course you can use a calculator for these if you need to. Okay, so if I'm going to plug in for the 111, I'm going to do 0.15 times 1, which is just 0.15. Now the 0.40 times 11, that's going to give you $4.40. So altogether, when I add 440 plus 15 cents, that's going to give me $4.55. That's the profit he would make off of donuts that are made by buying 1 glaze and 11 jelly. All right, so now let's do 1, 1 and 11, 1. 1, 1 should be easy. 0.15 times 1 plus 0.40 times 1. That's just going to be 15 cents plus 40 cents. That's only 55 cents. He's not going to make much profit off of that. Okay, so not a good scenario. All right, I'm going to do the other one over here. The other one is 11, 1. So for that, he's going to do 0.15 times 11 plus 0.40 times 1. So 0.15 times 11, that's $1.65, plus that's just 40 cents. So that's only going to give me a total of $2.05. So you should be able to see that the one he is going to make the most profit off of is this one here, because he's going to make a profit of $4.55. So that equates to making buying 1 glazed and 11 jelly. Okay, obviously he's going to make more money off of the jelly donuts. Okay, that's his maximum profit. So that gives you an indication of another example. Now I'm going to send you guys some more practice with linear programming word problems, but I wanted to at least give you the rest of your notes that you could fill in there.